In this video, we're going to learn how to use polynomial long division. Now, polynomial long division is very similar to numerical long division. The only difference being numerical just deals with numbers, while polynomials deal with terms with different degrees. So let me just show what normal long division looks like, and we can compare the two. So your first question that would come up would be like, how 21 divides into 67 how many times? Well, you would say 3. So you put a 3 up there above the 7 because that's the place it would be over. And then you would go ahead and subtract. So you'll have 67 minus 3 times 21, which is 63, giving me 4. And then you would just bring down that 2. And you would ask yourself a very similar question again. 21 divides into 42 how many times? Well, that's 2 times. And then you would take that information and be, okay, 2 times 21 is 42. And then you would subtract that away, and you would have a remainder of 0. And you'll learn that 672 divided by 21 is 32. Now, what does that look like if I did it with polynomials instead? So here, instead of using 21, I'll use 2x plus 1. Just imagine x is equal to 10 if you want to compare the two. Then 6x squared. 6 is the hundreds place. 10 squared is 100. Plus 7x for the tens place. Plus 2 for the ones place. Now, your questions remain almost the same. You ask yourself, 2x plus 1 divides into, I'm going to look at, if it was 67 before, I'm going to look at 6x squared plus 7x, how many times? Before you would say 3, but this time, since it's in that tens place where that 3 was, the tens place here is x, so I'll say it divides into it 3x times. So then I would do, okay, what's 3x times 2x minus 1? That would be 3x times 2x is 6x squared. 3x times 1 is 3x. And then I'll subtract that out of the expression. 6x squared minus 6x is 0. 7x minus 3x is 4x. And then you would carry down the 2, just like you would have over here. And then you ask yourself another similar question. That 2x plus 1, we said 21 in the previous example. The 2x plus 1 divides into 4x plus 2 how many times? Well, twice. So 2 times 2x plus 1 is 4x plus 2. I'll subtract that away. It'll give me a remainder of 0. 4x minus 4x is 0. 2 minus 2 is 0. So I get 0. So what I can say is that 6x squared plus 7x plus 2 divided by 2x plus 1 is equal to 3x plus 2. As I went along, like that 3 and 2 made 32, 3x plus 2 up there gives me 3x plus 2 as my solution. So now let's try this with another one, but not look at this number example. But again, the idea is that the mechanics of numerical long division are the same in polynomial long division. So we're doing 4x squared plus 23x minus 16 divided by x plus 5. So I'll write x plus 5, and I'll put 4x squared plus 23x minus 16. Now before, I kind of used this as an example to see what I need to, how many times does that term divide into the other set of terms. But here's the trick of how to figure that out. Right now I'm looking for how many times does x plus 5 divide into the first two terms of my polynomial, which is 4x squared plus 23x. The way you find that number is just to take 4x squared and divide it by x. So what is 4x squared divided by x? 4x. So I'll say it divides into it 4x times. The idea is that you want to get rid of the 4x squared term when you go to subtract, just like we wanted to get rid of that 6 and the 6x squared earlier. So 4x times x is 4x squared. And then 4x times 5 is 20x. And I'm going to subtract that from my polynomial. So 4x squared minus 4x squared, that's 0. 23x minus 20x is 3x. And then I'll carry down the negative 16. And again, now I'm asking myself, x plus 5 divides into 3x, the next two terms, 3x minus 16, how many times? You do it the same way. This x, 3x divided by the x is what you're looking at, those leading terms. That gives you 3, so it would divide into it 3 times. So then 3 times x plus 5 is 3x plus 15. We'll subtract 3x minus 3x is 0, and very common mistake is when these are opposite signs, many people will add them together to get negative 1, but I have to subtract the 15, which will give me negative 31, which is my first remainder. So my answer would be 4x plus 3 with a remainder of negative 31. A better way to write this answer would be this. Right now I'm doing 4x squared plus 23x minus 16 divided by x plus 5. When I divide by it, I get 4x plus 3. But the remainder is good to put as a number plus the remainder, negative 31, over your divisor, x plus 5. Kind of like a mixed number if you were to work with those. In this case, since I'm doing plus negative 31 over x plus 5, I could write my answer as 4x plus 3 minus 31 over x plus 5. Now, let's talk about another situation. You can often use division to check if something's a factor. If you get a remainder of 0, that means that what you divided by was a factor of that polynomial because it divided evenly, giving us those two factors, 2x plus 1 and 3x plus 2, that can multiply to give me 6x squared plus 7x plus 2. While down here, x plus 5 is not a factor because I got a remainder of negative 31. It's the same way that we know that 24 divided by 6 gives you a whole number because 6 is a factor of 24. So let's check this. So we're going to divide our polynomial by x squared plus 1. Now, one thing to be on the lookout for when you're dealing with polynomial long division is sometimes you won't see every term. Like we'll see here, the linear terms in both of these polynomials are missing. A good way to avoid making any mistakes is to add in that term with a coefficient of 0. So we get 3x to the 4th minus 4x cubed plus 12x squared, and we'll put a plus 0x for that term we're missing. The same with the divisor, x squared plus 0x plus 1. It's all just keep track of everything. But now we'll do the same type of method. How many times does x squared plus 0x plus 1 go into 3x to the fourth minus 4x cubed plus 12x? The trick is just to look at the leading terms first. So 3x to the fourth divided by x squared gives me 3, and x to the fourth divided by x squared is just x squared. So first, I get 3x squared. I forgot my square over here by the 12x. So now I'll do 3x squared times my divisor. So 3x squared times x squared is 3x to the fourth. 3x squared times 0x would be 0x cubed, or just 0. I like to match it just so I know where it belongs. And then 3x squared times 1 is 3x squared. And then you subtract those two. So 3x to the fourth minus 3x to the fourth is 0. Negative 4x cubed minus 0 is still negative 4x cubed. And then 12x squared minus 3x squared is positive 9x squared. And then you'll carry down your other terms. Then we go through the same process. Now you're thinking, how many times does x squared plus 0x plus 1 go into negative 4x cubed plus 9x squared plus 0x? How many times? Again, I'm looking at my leading coefficients. So I'm going to see how many times does x squared go into negative 4x cubed. Simplifying that, I get negative 4 and x. So minus 4x. So then I'll do negative 4x times x squared plus 0x plus 1. So negative 4x times x squared is negative 4x cubed. Negative 4x times 0x is 0x squared, or just 0. And then negative 4x times 1 is negative 4x. And I'll subtract, and I'll get negative 4x cubed minus negative 4x cubed, which is 0. 9x squared minus 0, which is 9x squared. And then 0x minus negative 4x, which is plus 4x. And then plus that 5 when you carry it down. And we'll do this one more time. How many times does x squared plus 0x plus 1 go into 9x squared plus 4x plus 5? All right, so I'll look at how many times does x squared go into 9x squared, which is 9 times, so plus 9. So I'll get 9 times x squared, which is 9x squared. 9 times 0, which is 0x. And then 9 times 1, which is 9. Subtract that away, and I'll get 4x. The 9x squareds cancel, and then 5 minus 9 is minus 4. So I'll get a remainder of 4x minus 4. And usually you know to stop whenever the degree of your divisor is greater than the polynomial you have left. So x squared is bigger than x in degree, so we stop there. It's the same as saying if this was 100, this would only be 40 max. So there's no way 100 goes into 40. But I have a remainder, so I would say no, it is not a factor because there was a remainder. Now let's see if x minus 2 is a factor of the polynomial x to the fifth minus 32. And if it is, we'll rewrite p of x as a product of those two factors. Meaning x minus 2 times something else, the same way we saw it over here. So I'm going to do x. How many times does x minus 2 go into x to the fifth minus 32? Now I'm seeing here there's a lot of missing terms from x to the fifth down to the constant. And I'm going to fill them all in with 0 coefficients. So how many times does x minus 2 go into x to the fifth plus 0x to the fourth plus 0x to the third plus 0x squared plus 0x minus 32? So again, how many times does x go into x to the fifth? Well, x to the fourth times, and then x to the fourth times x minus 2 is x to the fifth minus 2x to the fourth. And then I'll subtract. X to the fifth minus x to the fifth is 0, and 0x to the fourth minus negative 2x to the fourth minus a negative is a plus, give me positive 2x to the fourth. And this time, instead of bringing all the terms down, I'm just going to bring down what I need, which is 2 terms. So now I have plus 0x cubed. Now how many times does x go into 2x to the fourth? 2x to the third time. So what's 2x to the third times x? That's 2x to the fourth. And 2x to the third times negative 2 is negative 4x cubed. Subtract. And again, minus a negative gives me 4x, positive 4x cubed. And the 2x to the fourths cancel. And then I'll bring down the next 0. And how many times does x go into 4x cubed? Well, 4x squared times, of course. So 4x squared times x is 4x cubed. And in case you're not seeing how I'm getting 4x squared, I'm just dividing 4x cubed by x to get 4x squared, just like I did in the previous step. And then 4x squared times negative 2 is negative 8x squared. Then I'll subtract that. So 4x cubed minus 4x cubed is 0. And 0x squared minus negative 8x squared is positive 8x squared. Then I'll bring down the 0x. Hopefully you're starting to see the pattern here. How many times does x go into 8x squared? 8x times. Multiply 8x times x minus 2. So 8x times x is 8x squared. 8x times negative 2 is negative 16x. Subtract that away. 8x squareds cancel. I'm left with a positive 16x because you subtract the negative. Bring down the negative 32. Again, how many times does x go into 16x? Positive 16 times. And then what is 16 times x? 16x. 16 times negative 2 is negative 32. Subtracting these two gives me 0 for the remainder. So it is a factor for sure. So I can rewrite p of x, instead of x to the fifth minus 32, I can rewrite it as x minus 2 times x to the fourth plus 2x cubed plus 4x squared plus 8x plus 16 as those two factors. And that is how you use polynomial long division.